Algebra 2 is the study of functions, and we have been studying functions so far. We've talked about linear functions, quadratic functions, polynomial functions, but we haven't actually defined what a function is. Now we're gonna define a function today, and we're also going to look at this definition through the lens of the rule of 4. Remember that any function can be described 4 different ways: as a written description, a table of values, a graph, and an equation. So what we are going to do is go through the written description first. Make sure you have a piece of paper and you are taking notes. So the written description of a function, we could say a function is a relation where every x is paired with exactly one y. We could also say every input is paired with exactly one output. Or we could say every element of the domain is paired with exactly one element of the range. These are all sort of synonymous definitions. Now, if we look at this, kind of what's the same about each one of these, well, we have an x, an input, and an element of the domain. We also have y, an output, and the range. So x, input, and domain are all synonyms. Y, output, and range are all synonyms. The other thing that we have going on with this definition is that there is exactly one, that these things are paired where x is paired with exactly one y. Every input is paired with exactly one output, and every element of the domain is paired with exactly one element of the range. So there is this oneness. If we think about this in terms of a table of values, an x, let's say 1, is paired with exactly one y, say 1. An x, 2, is paired with exactly one y, 4. What that means is I can't say that 2 is also 3, because then we would have 2 paired with 2 different y values. So we are not going to do that. So let's get rid of that. Let's say we have 3 and 9 and 0 and 0. You might be sort of noticing that there's a relationship between these numbers. Perhaps I'm trying to do the equation y equals x squared. Well, if I said -1, -1 squared is 1. And now the question is this allowed? Are repeating y values allowed? Is that okay? Well, let's think about this as a function. We'd have 0, 0, 1, 1, -1, -1. We'd have 2, 4, 3, 9 is up there, so we're not going to graph that one too far up. We might also have -2, 4. And so when we plot this function, we see, oh, there's our standard parabola. And I already said it's a function. And we know that it's a function because every x is paired with exactly one y. And some of you may be sort of screaming to your screen at home, vertical line test. Yes, you're right. There is a thing called the vertical line test. The vertical line test tells us if something is a function if, when you draw a vertical line through the function, you only ever pass through one point. You never pass through 2 points. And what that is actually doing, what the vertical line test is showing you, is that for every x, there is only one y. For every x, there is only one y. You're not going to have multiple y's for each x. Let me show you an example of where that might occur. So let's just get rid of all of this. There it goes. Goodbye. Now, what if we had a different situation of values? What if we had something like, what if our graph, let's start with the graph. What if our graph looked like this? Already we know, oh no, not a function. Definitely not. It doesn't pass the vertical line test. It doesn't pass the vertical line test. Well, so if we were to list these values, I'd have 0, 0. I'd have 1, 1. But I'd also have 1, -1. And I'd have 4, 2. And I'd also have 4, -2. Right? What's happening here, this is a sideways parabola. And a sideways parabola, you didn't know this, but let me tell you, is the equation x equals y squared. we can see clearly it does not pass the vertical line test. We can see clearly that there is not exactly one x, right? It's paired with different y's. 4 is paired with both 2 and -2, so that's no good, not a function. But we can also explore the equation a little bit further. If I were to solve the equation for y, so we do that so we can kind of think of this in terms of input and output. If I were to solve for y, I'd square root both sides, and I would get plus or minus the square root of x is equal to y. I might rewrite that, y equals plus or minus the square root of x. And now think about this. If I plug in a number for x, like say 4, if I plug in 4, what happens? I could get +2 or -2. And now you see, two outputs. We can't make a prediction about what x is or what y will be if we're given x. We have these two different options. So that's no good. It's not a function. Let's look at some examples and see if you can tell me whether or not it's a function based on the information that I give you. So let's get rid of that. Okay, and let's get rid of these. Okay, so let's say my equation is, or let's start with the table values, 1, 2, 3, 4, 5, and 3, 3, 3, 3, 3. Now, I didn't even need to tell you what my y values were because you should be able to know 1, 2, 3, 4, 5, different x values. It's okay. Here we have the constant function, y equals 3. It passes our vertical line test. We are all good. Okay, now let's do something else. Let's say I have 3, 12, and this is 3, and this is 4, and this is 2, and you should be thinking right now, wait, no, there's 2. But what if I'm like, it's 12, don't worry. Right now, it is a function because my x, 2, is still paired with the same output 12. So we're okay there. But if I do something like this, 3 and then, I don't know, 16, all of a sudden, whoa, no, not a function because my 3 here is paired with 2 different y's. So that can't happen. Okay, we're going to call it on this video, and we'll come back as a class and look at some examples.